Okay, question 7. I've just been reading this, trying to think what I'm going to do here. I'm not sure what use geometric reasoning means, but I'm going to go for this anyway. Look, first of all, if I look at the 1 plus root 3i, I think the modulus of that's 2, isn't it? And the argument of that one there, the argument is the inverse tan of root 3 over 1, so that's just pi over 3. So I'm going to start with that, and I'm going to actually start with the modulus part as well. So the modulus of z squared divided by w equals the modulus of z. Well, I can break those moduluses up. So this is the same as, we know the modulus of that's 2. So I've got 4 divided by the modulus of w equals 2. So I think the modulus of w is equal to 2. So these complex numbers we're going to find are going to have a modulus of 2. But now, looking at the argument, so, right, I can remember a little bit of first year stuff about arguments, that the argument of z squared divided by w was the same as 2 lots of the argument of z minus the argument of w. Now, we want the real part of this to equal 0. So if the real part of this is 0, that means it's only imaginary. That means the argument's going to be pi over 2, doesn't it? Or minus pi over 2, I suppose. All right, let's take the pi over 2. It does say there's 2 possibilities. So pi over 2. So look, this is what I'm thinking. I've got 2 lots of the argument of z minus the argument of w, and I think that's going to equal pi over 2. So that would tell me that the argument of w was going to be pi over 6 for that bit there. So my first option for my first answer is 2e to the pi over 6i. But also maybe there's a bottom one going down there as well. So just rather than rewriting it all again, so I think that's going to give me 2 pi over 3 minus the argument of w is equal to minus pi over 2. Just to clarify that, because I only got it as I was doing this, that if there's no real part, it could be an imaginary part going straight up, or it could be an imaginary part going straight down. So that's why I've got this minus pi over 2 here. So that gives me the argument of w is going to be, that's 4/6, 7/6 pi. And it doesn't tell me to change it, but I don't like 7/6 pi. I'm going to change that back again. So I'm going to go, that's e to the, take 2 pi off that, minus pi over 6i. They're my answers. We'll have a look at the answer and see what they've got.